to turn off the fan. Oh. Alright, so let's see here. How do I share link? Alright, so let me set that up a little bit further. Alright, so okay, so what I'm working on is like the linear regression of scikit-learn linear regression using the ISLR dataset, the advertising dataset. So what I did so far was I didn't even start as much as I should be doing, but it takes like a long time because I'm like I don't even really know how to program, so I'm just like learning as I go as well, just to achieve how to successfully model this data set. Right now, the advertising data set is just a beginner's testing approach. And I'm trying to go by the marketing plan, really. So I said this in my last stream on Sunday about the marketing plan. And I think today I'm going to work on trying to code it through the marketing plan. So let's see here, from sklearn import linear model, use ordinary least squares. So what I did was just import. So there was a ISLR dataset from the ISLR website. You can actually download that dataset, the advertising dataset. That's what I did. I imported pandas, pd.read csv, and next thing was advertising.drop, axis equals 1, advertising.head. So you see that I had to drop on name 0 because there was actually another column, which was basically just an added index column, but there's already an index here, so it seemed like I didn't even really need that. It was just an extraneous column that we don't really need. And then advertising head, just to see what's up. So right now I'm just figuring out how to plot the points. I've plotted the data points using scatterplot using matplotlib, but apparently I figured out that wasn't really enough. I mean, it's scatterplot, yeah, but it's like, you know, it's like maybe not. And so it's like maybe not. So I see that the data points seem like it doesn't have a linear relationship as sales increases. I'm gonna turn on some music too, my bad. Wonder if you can hear that. Let's see here. I like focus. You know what I like? I like the nerdy stuff, the video gaming stuff. Have you guys heard of the Animal Crossing one? Animal Crossing focus music with the rainy day. I mean, it's like low-key chill. You feel like it's raining, but it's really not. I mean, it's like low-key chill. You feel like it's raining, but it's really not. I mean, it's like low. Man, I laugh so weird. I'm like hearing myself. Alright. There's some people that study really hardcore. I've seen a girl that just studies 7 hours every day, relentlessly. Like, she records herself on stream. It's called like the thing is called Study Channel or something like that in YouTube. Yeah, Study Vibes. This one girl just studies like 6 to 9 hours a day. It's so insane. She must be really successful by now. The problem with overstudying is that you tend to get a little too perfectionistic. Like, I tend to become like that. I tend to put so much effort into it, whereas sometimes like I do so much, but is the ends really that worth it from the means? Maybe I'm overdoing it. Like, and then like my confidence level like just goes low and stuff like that. But anyways, enough about me like talking about that stuff. This is pretty much a vlog. I'm gonna change that up. Alright, so like I said, going back to this, there was a scatter plot coming in. And let's see here. Oh yeah. Yeah. Thanks, Wall. I don't know how to say your name. Walpurgis Nacht. I'll just say Wall. Definitely for sure. I'm gonna have to create a GitHub repository. Let's see here. I kind of don't want to use my default. Let's see here. Oop. science, big data, Python. I'm gonna put R as well. So I've created it, but so now can everyone upload to the repository? I'm really new at this now. Actually, I should not have done this. I should not have used my name. I'm not gonna use this. I gotta, you know what? This is fucked up. Hold on one sec. I'm gonna delete this. Sorry, man. This is so bad. What the hell? I actually like that part of the song. I'm gonna go back. Let's see here. Alright, so I think I'm done with that. I think I should put like resource channel in here. Alright. I think I did this. Alright, so I created a repository. Cool ML kids. Alright. Sorry, that took a long time to set that up. It was like over 10-15 minutes. Alright, I'm back. So where did I last talk about the plot of data points? Yeah, I like I said, like the scatter plot, you can see that it doesn't really look linear. Granted, before I go on to it, this is a single variable linear regression, so it's a simple linear regression. It's not multiple, it's just one single variable. And the single variable that I'm just using right now is advertising TV and sales. So it has nothing to do with the marketing plan, because the marketing plan is all about the multivariable linear regression, which I'm not going through yet. I'm doing it, I'm about to. But anyways, like, you'll see that there's like, it doesn't look linear, it actually curves up and then it fans out. And I don't remember when I did this, but I think this was like yesterday. I figured out that there was an easier way to actually plot the points without using scatter. It's called regplot using Seaborn. And Seaborn is a subset of Matplotlib. Seaborn is actually very, very good for like data visualization using machine learning and stuff like that. So this is already the least squares fit. They've already plotted it down using regplot. So advertising.tv, advertising.sales. I just learned this yesterday. But scattered KWS, S is just the size of the dots. So 10 is actually small. So just to separate it out, because if it's any bigger, it'll just overlap. And then I found like another website like these things, which is extremely important for me because it's very similar to R, where if you use LMFit or LM something like that, and then you use summary LM on R, it gives you this already, but I didn't know how to do it, and I didn't know there was a Python version of this too. So I had to look at that up yesterday. So here's the results. So basically, I was just playing around with this a little bit. Wanted to know. So we're summarizing all the multilinear regression, but I don't want to do that right now. I was just playing around. I think I should go cut back and just use TV as the independent variable. So we're just still using only simple linear regression. In fact, I don't even need this. Just use this. Advertising.tv. And apparently you have to use fit after that, and then you can summary based upon this result. Oh, hold on, so I just did this yesterday, so let me start all over. This part is actually kind of something that you actually have to know. The dependent variable, sales, obviously. So this is the y-axis, this is the x-axis. You can have a list of x-axis just to make it as a multilinear regression, but let's just use a single. For independent variables, so dependent variables is sales. So r squared is 0.897. So what that means is that if it's 0 to 1, r squared always has a percentage between 0 and 1. And the closer to 1, the closer that there is an actual relationship between x and y, I think. And this is why I'm glad that I'm actually streaming this, because, and saying this out loud, because I may not be right and I'm gonna have to make sure. Because sometimes if I study and I don't talk and hear myself, I probably just like skip over like the details. I'm trying to find where r squared is. Very close. So apparently, using TV and sales. Okay, so I was wrong. I'm so glad I corrected myself. R squared. If it's closer to 1 like this is really close to 1. It's 89%. And if it's close to 1, it has a small residual error. If it's close to 0, like less than 50%, it's definitely a serious problem. Meaning that this linear regression line, this line of fit, this least squared fit, this least squared, I gotta really correct my terminology. This least squared fit would be extremely off, or that the data is actually really off in general. I'm like learning as I go. I'm just talking just to learn, to teach myself. So r squared is basically, if it's closer to 1, then we have a small residual error. If it's closer to 0, there's a serious problem. Adjusted r squared, I don't know what that is, but I think we learned that we will learn that in chapter 6. F statistic, it's super high. That's no big. This is irrelevant because this actually only is only relevant for multilinear or multilinear regression for multiple independent variables. But since we're only using TV, TV and sales already have a direct relationship with each other, and so therefore the F statistic is already really high. I guess, no, well, you know what? I guess F statistic can work for simple linear regression. But it's most effective using multilinear regression, because if you use a single linear regression, and if F statistic is only like 100, there might not be a relationship. But that doesn't make sense, because you can already tell visually that it's going up. As the sales is rising, the TV amount is higher, the sales is actually higher. So let me check. Alright. I'm being thorough here right now. By the way, I'm really sore right now. So yeah, the F test is a catch-all term for any test that uses the F distribution. In most cases, when people talk about the F test, what they are actually talking about is the F test to compare two variances. However, the F test is used to a variety of tests, including regression analysis, chow test. Yeah. So the F test is there's always going to be a positive number because variances are always going to be positive. Interesting. The equation for comparing two variances is okay, whatever. I don't really care. When I look at like functions, I really need to like discipline myself to know this stuff, but it's so hard. I don't really come from a math background, so it's a little hard for me to soak it in compared to just reading it. The F test must be approximately normally distributed. The larger variance should always go in the numerator. If you are given standard deviations, they must be squared to the variances. Yeah, blah, blah. I might fall into the rabbit's hole a little too much. Maybe I'm putting way too much effort into this tiny detail. Oh, okay. Oh, man. That's right. The F statistic only tells you between multiple populations are significantly different. So let's say TV and radio, they don't have correlations with each other. They're statistically significant. You create a null hypothesis saying that all of these independent variables have no relation with each other, or that there is a relationship, and then an F statistic, if it's really high, it'll tell you that there is a relationship with between. If it's really high, there should be no relationship between each other. If it's low, there might be some correlation, meaning that it'll meet the null hypothesis. We have sufficient evidence to prove that there might be a null hypothesis. Okay, I put way too much effort into finding that out. But all in all, it's absolutely irrelevant for simple linear regression. Just know that. I don't know what this is yet. I probably will learn this in Chapter 6, AIC and BIC. I think that's like the... It's like a measurement if... if there's a significance using different values that has, I mean, I think this is just a, if there's not enough data points, if the n is small, we could use AIC and BIC to determine if if each of the independent variables are significant, statistically significant, that contributes to the dependent variable, or not. I don't know, but I think that's what it's like, AIC and BIC. So this is irrelevant because we're still only using advertising TV. So most of these are actually irrelevant. R-squared is definitely relevant. There's 109 residuals. The number of observations 200. Original least squares. Ordinary least squares model. Ordinary least squares regression results. I've actually learned that from here. Oh no, not this one. Sorry. Where did I learn? Did I not save it? I could have sworn. Oh, ISL study. There we go. Yeah, I found out from this website. This thing. ConnorJohnson.com. It's really nice. Yeah, so he has the same thing too, which is really nice. What is dot fit? Okay, so what? Okay, so the adjusted R-square is actually more relevant to multiple linear regression. Okay, I get it. This website is so much easier to understand in compared to ISLR. So basically the F statistic is saying that the null hypothesis of the F test is that the data can be modeled accurately by setting the regression coefficients to 0. The alternative hypothesis is that at least one of the regression coefficients should be non-zero. So let me write that. I think I've already wrote that already. I mean, like I said on Sunday or Monday yesterday, that So this is the null hypothesis. So B of TV equals, you know, newspaper or whatever, yada yada yada. I cannot spell. Radio? I cannot write in tablet. Equals 0. That's the null. The alternative hypothesis is basically all of this, but it equals, does not equal 0. Actually, it's greater than 0. Non-zero. Interesting. But according to this, the alternative hypothesis, at least one of the regressions should be not 0. At least. So, again, according to that book that we read in ISLR, this is how you write the null and the alternative. So all this does not equal to 0. If the average distribution provides a p-value that is lower than some threshold, 0.05, then we reject the null hypothesis and say that our model is in fact doing something with its life. If the f-statistic is computed as a ratio of 2, so now we have the nice statistics. Man, I don't want to learn this. God damn it. I mean, is it really that important for me to know that part? I mean, like, if I work at a company, and if I get a technical interview, would I have to be tested on this? If I want to do, like, some sort of machine learning job position out there? Huh. Alright, you know what? I'm having some conflicting information here right now. According to the ISLR, f-statistic is, is that the same thing? Deciding on important variables. So if you have yeah, it says the first step in a multiple linear regression analysis is to compute the f-statistic and to examine the associated p-value. Okay. Where's the p-value in that? It's literally not there. Oh, wait a minute. If we conclude on the basis that the p-value that at least one of the predictors is related to the response, then it is natural to wonder which are the guilty ones. We could look at the individual p-values, but if p is large, we are likely to make some false discoveries. It is possible that all the predictors are associated with the response, but it is more often the case that the response is only related to a subset of the predictors. It is possible that all the predictors are associated with the response, but it is more often the case that the response is only related to a subset of the yeah. This makes sense. The task of determining which predictors are associated with the response in order to fit a single model involving only those predictors is referred to as variable selection. Yeah. Ideally, we would like to form a variable selection by trying out a lot of different models, each containing a different set of predictors. For instance, if p equals 2, the number of predictors is 2, then we can consider 4 models. A model containing no variables, a model containing x1 only, x2 only, 1 and 2. But if p is 30, then that's too many models. So we'd have to use 4 backward and mixed. But really, this data set is only literally just 3. 3? P equals 3, pretty much. But it is right. I mean, I guess he's right. This one doesn't really go over F. Oh. Maybe I'm wrong. Where is it talking about? Okay. Is there a relation between the response and the predictors? Recall that in linear. Yeah, so yeah, this is the null, this is the alternative. At least one is non-zero. This hypothesis is performed by using the F statistic this. You know what's really funny though? Let me I have R. I want to know how accurate this is compared to R. I'm gonna test this. What if Python is wrong? R Studio. R Studio. I already loaded my thing. ISLR. I did not know ISLR contained a lot of data sets in the R package. That's a lot. That's decent. Not a lot, it's just decent amount. Where's the advertising. God. Okay, you know what? What is R read CSV? Oh, read.csv, right? Yeah, okay. You know what? Fuck it. Advertising. We need to do that. Home. Where is that? I know I have it. Desktop. ISLR study. Oops. God. Okay. ML practice. No. Chapter 3. Dataset. I'm very concerned, actually. I'm very concerned. So, I set up the R version of this. If I did this, I'm gonna do lm.fit equals lm. Oh, attach. That just basically attaches the header, so I don't have to write too much. Was it TV? See, okay. You notice that this thing, summary.mlmfit, is basically the same thing as the Python version of this right here. See? You'll notice that the S statistic is through, I guess that doesn't matter. But it has the associated p-value. Why is F statistic 1733 and this one's only 312? That's fucking weird. It's the same dataset, I know it. It's in the same thing. Let's see here. I guess it doesn't matter because it's just single. It really doesn't matter, I guess. It's definitely less than 0.005. TV is the p-value 0, which is basically the same. So I have to fix my stream for some reason. Alright, I'll hold on one sec. I'm gonna take this out for one moment. Sorry, guys. Oh, whoops. I guess I have to turn this off first. Hold on a sec, I'll be right back. Why is that not optimal? How is that not optimal? Nope. Alright, so I'm losing track. Oh yeah, that's right. So I just used, this is the R version of what I just did as opposed to the Python version of what I just did. I guess it doesn't matter, the F-statistics, because it's, again, it's really just only like the relevancy of what y is, or independent variable is, like which ones are like the most fitting and stuff like that. To determine if there's any relationship between the response and its predictors. That's x takes to take on the value close to 1. On the other hand, if it's true, if the alternate hypothesis is true, we expect f to be greater than 1. For S, this is a multiple linear regression model obtained by regressing sales, radio, TV. In this example, S is 570. Since this is far larger than 1, it provides compelling evidence against null hypothesis. In other words, the ISLR suggests that at least one of the advertising media must be related to sales. However, what if the S has been closer to 1? Okay, yeah, blah, blah, blah. So basically, we need a, obviously TV, well, regardless if it's 1,700, I mean, it's just one thing. And then there's clear evidence, even 312 in the R version, as opposed to this version, is clearly way better, you know? With less than, basically 0, with p-value of 0, so that's pretty good. It doesn't even matter. I don't even know why I was like. I just really want to know what F statistic was, guys. This doesn't even. We're not even in the multiple linear regression portion of things. All right. What is the next step that I have to do? I don't want this anymore. Don't save. I'm gonna quit out of R. Going back to. So we know that TV is definitely related to sales, very much so, with a very low P value, which is really good. We know that all this is just only pertaining to multiple linear regression, pretty much, except the R squared, which is good. It has really good, the line of fit has a really good residual, low residuals. Oh, right. Now I remember what I was supposed to do. I was supposed to follow J. Wormhoven's thing. In fact, I think I'm going to change my thing again, like my study, to follow J. Wormhoven at first. But I wanted to do my own thing as well because I kind of wanted to mimic R's way of looking at the summary using the ordinary least squares. What is this? So yeah, he's using simple linear. He uses SNS route. That's where I got the plot from this guy. He has the regression coefficients, the RSS. Oh, that's how you calculate the RSS. Okay. So that's what I want to do next. I want to calculate, since I already have R squared, I want to calculate the RSS. Because there's no RSS in this summary, so we're going to have to figure it out ourselves. So, calculating RSS. That's the residual sum of squares, which is another method of evaluating your model. And our goal is, our hope is that the RSS will have small errors, or a small score, because the smaller the score is, the better, and the more accurate our prediction is from our TV and sales data. I don't know if I wasted too much time just figuring F statistic out, but that was a long time. I feel like I'm gonna forget about F statistic all over again tomorrow, and I have to like fucking figure it out all over again. I'm just gonna say that the F statistic is basically just a way to find a relationship of the response variable. Sorry about that. So before we start with RSS, let's figure out what RSS really means. Apparently in this website it doesn't tell you what RSS is. That's okay. Calculating RSS. RSS is a method to evaluate data using I actually don't know. See, there's a difference between studying it and then just recalling it back. To know what that if you truly learned it. I just now realized that talking when you're studying is so much better than just studying quietly, because you're recalling things that you're supposed to learn. You're recalling back what you've just learned, and sometimes when I study, like I'm like, oh, this makes sense. Okay, I'm moving on, like without any like thought, and then like once I come back to it, I forget what it was before. And then that's I guess that really like sets the difference between someone who performs well in a technical interview, as opposed to who just studied a lot and didn't, maybe. Huh, okay. Still flickers. $4,500 kbps. Are you serious?